Hi guys, today let's discuss the LeetCode question 392 is subsequence. Given two strings s and t, return true if s is a subsequence of t or false otherwise. A subsequence of a string is a new string that is formed from the original string by deleting some can be none of the characters without disturbing the relative positions of the remaining characters. That is, ACE is a subsequence of ABCDE while AAC is not. So in this case, if we are removing the characters B and D from the original string, we get ACE. That is a string that we wanted to compare with. While AEC is not, because in this case the relative positions of the characters is changed. So that is the reason AEC is not a subsequence of ABCDE. Let's go to the example 1. In this example 1, our new string is ABC and our original string is AHBGDC. So in this case, if we are deleting the characters and H and GD, we get ABC. So in this case, we are returning true. Let's go to the example 2. In the example 2, our new string is AXC and our input string is AHBGDC. So this string is same as the example 1. So in this case, the character X is not found anywhere in this string. So that is the reason we are returning false. Let's go to the constraint section as well. So s dot length is between 0 and 100 and t dot length is between 0 and 10 to the power of 4. So the important point to be noted here is s dot length and t dot length can be 0, which means it can be an empty string. And s and t consists of only lowercase English letters, because other characters like numeric characters or special case characters are not will not be provided in the strings. So let's go to there is a follow-up to this question. Let's look at the follow-up as well. Suppose there are lots of incoming s, say s1, s2, so on till sk, where k greater than or equal to 10 to the power of 1, 10 to the power of 9, and you want to check one by one to see if t has its subsequence. In this scenario, how would you change your code? So this follow-up means like there are many incoming s, so we have to cache our from the given inputs, we have to cache in such a way that we will be optimizing for our time complexity. So how will we change our code? So I hope it is very clear from this explanation. Let's go into the explanation part of it. For the purpose of explanation, I am going to consider my S string to be ABC and T string to be AHBGDC. In this explanation, we are going to discuss about the optimized solution, and also we are going to discuss an approach to solve the follow-up question. So in order to solve this using this optimized way, we are going to make use of two-pointer approach. So in this two-pointer approach, I am considering an ith pointer to be positioned at the 0th index of the S string, and the jth pointer is positioned at the 0th index of T string. So then we are going to compare the characters at the ith index and also the character at the jth index. Whenever the characters at the ith index and jth index are same, then we are going to increment both the ith index and jth index. If the character is not same, then we are only going to increment our jth index. So in this case, the character at ith index and jth index are same and it is A. So what are we going to do? We are going to increment both the ith pointer as well as the jth pointer. Yes, we have incremented the ith pointer and jth pointer. Then we are again going to compare the character at the ith pointer and the character at the jth pointer. In this case, the character at the ith pointer and jth pointer are not same. So in this case, we are only going to increment the jth pointer. Now we have incremented only the jth pointer alone. Then again we are going to compare the character at the ith pointer and the jth pointer. In this case, the character is same and it is B. So then we are going to increment both the ith pointer and jth pointer. Now we are going to compare the ith pointer character and the jth pointer character again. The character is not similar, so in this case we are only going to increment our jth pointer. Now again the character at ith pointer and jth pointer are compared and the character is not same. So in this case again we are incrementing our jth pointer alone. After incrementing the jth pointer, we are again comparing the character at the ith pointer and jth pointer. In this case the character at the ith pointer and jth pointer are same and it is C. So then we are going to increment both the ith pointer and jth pointer. After incrementing both the ith pointer and jth pointer, we have reached the end of the string for a string as well as the end of the string for the teach string as well. So in this case we return true. There may be cases where the end of the S string cannot be reached even after iterating to the end of the T string. Then in that case we can safely say that the subsequence cannot be formed with the original string. So in that cases we return false. So we return true only when the end of the S string can be reached by the given T string. So only in that cases we return the output as true. So in this case the end of the string S can be reached, so that is the reason we are returning true, and it is irrespective of whether we are reaching the end of the string T or not. To solve for the follow-up question, we will be using memoization technique. In this memoization technique, we will be passing the original string T and we will be storing it in a form of a list of dictionaries. The reason we are storing it in the form of a list of dictionaries is for the efficient retrieval for any incoming string S. If we look at the 0th index, the 0th index of this memo list is going to store all the characters in the string T as a keys, and the value is going to be the current index position of that particular character in the string T plus 1. The reason why we are storing it as a plus 1 will be much more clear in the next steps. Then after storing this memo list, we are going to have two pointers. One is pointing to the string S and the other is going to point to the memo index. Initially we are positioning the first character in the string S and also the 0th index in the memo list. Then we are going to check whether the first character in the string S is the 0th index of the memo dictionary. Then we find at this position A1. Then with this value we are going to traverse this memo list. Since this character A is found inside this memo dictionary, we are going to update these pointers. Then we are going to check for the next character, that is the character is B in the string S in the dictionary at the first index. Then we are finding this one at this position. With this we move on to that index position 3. Now this character C is found at the 6th position. So we are going to consider this. So then we are going to move to the 6th position. Now if we look at the string S, we have reached the end of the string S and we have found all the characters in the string S list of dictionaries. We have found all the characters. So that is the reason we are returning true in this case. In any case, if we are not able to find any particular character at any index position, we are going to return false. By this method, we can efficiently search for any character using O of 1 time complexity. So in order to find the entire string S, the complexity is going to be O of n. So this is an efficient approach to solve for the follow-up question. I hope it is very clear from this explanation. Let's quickly code this up. Let's code for the two-pointer approach first. let's have I comma j equal to 0 comma 0. So we have the two pointers are I and j, and they are initialized to 0 comma 0, and while I is less than length of s and j is less than length of t. So both these conditions should be satisfied. If any of this condition fails, then we are going to stop this the process of finding the subsequence. If s of I equal to s of t, then when this character is same, then we are going to increment our I pointer. And outside this if condition, we are going to increment our j pointer, because the j pointer will be incremented irrespective of whether the ith pointer's character is same as the jth pointer's character. Sorry, it is going to be t of j. Then we are going to return true if we have reached the end of a string I equal to length of s. I hope we are done. Let's quickly run the code. Yeah, let's quickly submit it as well. Yes, it is submitted. Let's comment out this code. Let's code up for the follow-up question using the memoization technique. Memo equal to, we are going to create a list of dictionaries for underscore in range of length of t plus 1 for I in range of, we are going to pass to this t string from the end, so it is length of t minus 1 till the minus 1 position. We are going to iterate in steps of minus 1, and memo of I is equal to memo of I plus 1 dot copy method to copy the I plus 1 dictionary. Then we are going to add up the ith character in the t string to this dictionary. Memo of I of t of I is equal to I plus 1. Then we are going to pass through this string s for character in s if character in memo of I. So let me create one more pointer to this memo list. So I is equal to 0. Initially it is positioned at 0. Then if this character is found in this memo of I dictionary, then in that case we are going to change this pointer to memo of I of to that character position. So where this character is found inside the t string. So once if this character is found, if this character is not found, then we are going to return false. If all the characters are found, then we are going to return true. Yeah, I hope we are done. Let's quickly run the code. Yeah, it is accepted. Let's quickly submit it as well. Yeah, it is submitted. Hope you liked the explanation. For more such videos, please subscribe to my channel. Thank you.